Solve exponential and logarithmic equations. Let's now solve a logarithmic equation, which is one that involves logs of variable expressions. And in order to solve this equation, we're going to have to exponentiate each side using base 4. So let's not forget that exponents and logs with the same base are inverses. So here's what that looks like. Sometimes people are a little lazy, they just do the following. And what ends up happening is that this cancels out, and we're left with 5x minus 1 equals 64. Add 1 to each side, divide both sides by 5, and we get x equals 13. All right, time to check that. Substitute it back into the original. Let me just erase this. And we get log base 4 of 64 equals 3. And well, we know that's true because 4 to the third power equals 64. So that is correct. You should always check for extraneous solutions. Doesn't matter what you're solving, but that is especially true with log equations because the domain is usually not all real numbers. So let's solve log of 2x, and you could put parentheses if you want, just to know that you're taking the common log of the entire value there, plus log of x minus 5 equals 2. Now if you want, you can first write it with the log base 10, that's your choice. And because we have the same log base and they're being added, we could use the log product property. There's that. We distribute. So we multiply 2x times x minus 5. We get log base 10 of 2x squared minus 10x equals 2. And now we exponentiate both sides. So what that leaves us with, after this cancels out, is that 2x squared minus 10x equals 100. Subtract 100 from each side. We could divide everything there by 2, and it's probably best to factor as you see there. You could use whatever method you want. All right, zero product property gives us x equals negative 5 and x equals 10. If we check x equals negative 5, I'm only going to check it into the first part over here. 2 times negative 5 is negative 10. Log of negative 10, can't do that because you got to ask yourself 10 to what power gives you negative 10. So that's a dead end. So x equals negative 5 is an extraneous solution. All right, what about if we check 10? So substitute 10 into the original equation, and I'm going to use the product property again. So log of 100 equals 2. Well, yeah, because 10 to the second power equals 100. So that tells me that x equals 10 is a viable solution. And if you check with the graph, you could see there that they intersect when x does equal 10, as you see highlighted there.